But anyway, nonetheless, we can get started. So I'll be referring to KML notes, College Matriculasi Labuan. I will be referring to their notes lah for tonight as my main my primary source lah to teach you guys. Okay, so if there is any like issues in my explanation or my like how I teach, let me know. Okay, whether you guys want to PM me, like private message me or whatnot, then I am open arms. You could do that. Okay, so let me find pencil. Okay, so wait, let me change my background because I realized that oops, the camera is turned on. Sorry. Yeah. Okay. So page settings. Okay. So numerical method. So what is our objective? Now, for now, we are just assuming that we can find an exact one root lah. In a way, for every functions currently that are given in this topic, everything has an exactly one root in that particular interval. Okay, meaning that they give us the interval and find the roots. Okay, so in this topic, before we start, you have to know how to graph functions, logarithm functions, exponential functions, linear functions, quadratic functions, because sometimes the question wants you to use the graphical method. Means that you have to show this root through graphing. Okay, but it's not not graphing, meaning that you have to sketch the particular function on a Cartesian plane. Okay, so yeah, so there are two ways. First is graphical. Now, in a nutshell, it's just basically you graph the particular function and then you show where the intersection between those two functions. Okay, because they might give you two functions and then plot it on a graph. And then if there's an intersection, then that is your answer lah. That is the root. Okay. So that is for graphical. Basically, I am explaining in a nutshell before we go into the tutorial questions. Okay, so algebraic. Basically, algebraic meaning that they give you an interval. Okay, interval. Let's say they give us a closed interval, whatever lah, open and close, but I rather use closed interval AB. Then they're trying to say, okay, for now, your syllabus only covers like only what exactly one root. Because later on, if you are interested in mathematics, you'll be learning, okay, there are a couple of theorems where they are saying, okay, there at least one root in that particular interval. Okay, but then you have to use another theorem to confirm your like your hypothesis, like meaning that okay, there is at least one root. But is there exactly one root? So in a higher level, you will be learning those particular theorems. But for now, in your syllabus, you will be dealing with only exactly one root, so you don't have to worry whether there is more than one root. Okay. So let's go. Okay. So for algebraic, basically they're saying, okay, if f of a is larger than 0 and f of b is less than 0, meaning that okay, there has to be a root. Because if I graph this out, okay, let's say here's our continuous function, and then here's our endpoints a, b, and as you can see, for f of a, just here, the value is negative, while f of b over here, the value is positive. So this indicates that there is a root, okay, or exactly one root. I would rather say it as exactly one root for this continuous function. Okay, so there exists one root, at least one root, but still there is one root between a and b. Okay, because we already confirmed through our algebraic approach where f of a is less than 0, but f of b is bigger than 0. So okay, this means that it has to intersect. First, we know that it is a continuous function in a way, right? It is a continuous function. So this has to set at the x-axis, meaning that this will be our roots. Okay, where f of c is equal to 0. Okay, but if you guys are interested in learning more, you could look it up. Intermediate value theorem. It's a theorem where it helps us to determine the root to show there is a root. Okay, basically for now we are trying to say there is a root in the interval. For graphical, yeah, like I said, you have to just sketch the graph lah. Okay, so the real roots are the points of intersection. Basically for graphical, the real roots are the intersection. For example, if I graph one here, let's say I have a parabola or a quadratic function like this one. Let's say I start with 0 until infinity. It's kind of ugly, but anyway, okay, like this. So, okay, and then you have a linear function, which the slope is 0, is negative, the value is negative. Okay, so this intersection in particular is the root, the real root. Okay, for now you'll be dealing with real roots. Intersection between those two functions, y1 and y2. Okay. All right. So, is there any questions so far? Any questions? Hopefully, Nana. So, no, eh? Okay. All right. Let me read a bit in the initial. No, all right. Thank you. Can be located approximately. Yeah. So, what I showed you just now is just basically just trying to say to the reader or to the examiner, okay, there is a root in this particular interval. There is a root, but then the examiner asks, what is the value, right? What is the value? But before we get into that, let us go through the tutorial questions. Okay, so all right. Honestly, right, there is only one. Yeah, because in your syllabus you'll be dealing with only one root lah. Yeah. Sometimes I got confused because I usually deal with there at least one root or more than that. But okay. But anyway, okay. So I'll be using ChemL's tutorial questions. Okay. So this particular question asks, by sketching the graph of y sub 1. Okay, we have y sub 1 is equal to ln minus x minus 3. Okay, and then we have y sub 2 is equivalent 1 over x. Okay, show that there is only one real root for 1 over x minus, okay, basically show us that 1 over x, there is a real root, minus line minus x minus 3 is equal to 0. So show this, we have to show. But the question wants us to show by graphs lah. We have to sketch the graph. So it is very important to not forget about your previous semester about sketching the graphs. Okay. Luckily, you guys are sketching simple graphs lah anyway. Okay. So first, if you want to sketch the graph, you have to know the domain. Okay, you have to know the domain. So for y1, what is the domain for y1? Okay, so as you recall, for logarithmic functions in here, it has to be bigger than 0 lah. Okay, it can't be 0 or less than that. It has to be larger than 0. So in a way, if I write my domain here, let me just say that negative x minus 3 is larger than 0. And then solve this inequality, and then you will get x is less than negative 3. Yeah, x is less than negative 3. So this is our domain. So if I write it down, I would like to write it down in interval form. Okay, remember interval form from your previous semester. Okay, so I write down D, y1. D stands for domain. Okay, it's just a alphabet or a letter to indicate that I am writing down the domain. So here it is. So negative exclusive, yeah, exclusive, yeah, because infinity exclusive, meaning that it's a curve parentheses. Okay, curve. Yeah, so parentheses. Sorry. Okay, negative infinity until negative 3, but negative 3 is not included in the domain. Okay. So now we have our domain. All right. Now we know that for logarithmic functions, the range will be like this lah, negative infinity until infinity. But then later on, I think you guys already learned about concavity, critical points, inflection points. All of those are useful to graph really complicated functions in the future. Okay, but for now, as long as you know your basic functions, you could graph it very nicely. All right. Okay, so basically, right, you write our axis here. Oops, sorry. Okay, right. So we know for ln of x of negative x minus 3, it should be like this lah. So, okay, like that. All right. Then here will be negative 3. Yep, like that. Okay, that will be negative 3. Wait, I think so. Is it? Wait, no, no, I am sorry. It's not negative 3. It's negative 4. Okay. So basically, there's an asymptote, vertical asymptote for this logarithmic function, which is negative 3, right? Just to let you know. But now we're going to graph the other function. Wait, do I need to write down the asymptote? Is it? Not sure. I don't remember. Sorry. But yeah, I think that that's our asymptote in a way. Yeah. Which is negative 3, right? Okay. So how about 1 over x, our second function. Now 1 over x is a reciprocal function. Okay, so you guys remember what is the domain for it? The domain is all real numbers except for 0. 0 can't be, because if we include 0, that is undefined. Okay, it's undefined. 1 divided by 0 is undefined, right? So you don't need to include in our current domain. And then our range, okay, our range is from negative infinity, 0, 0, infinity. Okay, so that is our range. Okay. Well, because, okay, if you want to know why I exclude 0, all right. Yeah. Okay, if y is 0, let's say y is 0. So this implies 0 is equal to 1 over x. And then we have 0. 0 is not equal to 1. So basically 0 can't be included. Okay, same goes to when x is equal to 0. Okay. All right. So sorry, y2 1 over x. So asymptote functions, recall back to your previous semester on how to graph them like this. Ooh. Sorry, I want to graph it nicely. All right. Okay. Okay. So as you can see here, this intersection is the real roots lah. So you already showed that the red circle shows that there are real roots, or only one real root. But yeah, I'm gonna follow syllabus for now. Only one real root. Okay. We show it geographically lah, or by sketching a graph. Okay, both functions on the same axis, and the intersection shows that that is the real root. Okay. So by the way, to the viewers on YouTube, okay, so if my graph is a bit wrong, do let me know. Okay, if I left something, just let me know. Right. All right. So for the three of you, any questions for this graph? Anything? Okay. So you see, it's a straightforward question, right? It's it's a straightforward because the functions are, well, it's okay lah. The functions are okay. It's not that complicated. But yeah, with enough practice, inshallah, you can do it lah. Okay. All right. Hopefully, our new member here also can catch up with my explanation. Okay. So now, okay. So how about the second question? Okay, thank you, Shafia. Thank you. Okay. So how about the second question? Let me create a new page here. So the question asks, show that there is a root lies between -1 and 0 for the function given. Okay. So basically, they give us a function, and then they give us an interval, -1. I don't know, between means that inclusive, exclusive. Okay, I'm gonna assume that inclusive lah. So they give us this function. Oops, sorry. F of x is equal to x squared. Oops. Yeah, something is bothering. X squared minus ln 2x plus 3. Now, yeah, they want us to show, but by using the algebraic method. Okay. But how do we do that? Okay, so algebraic method. So they give us the interval. we have to find, well, we have to show that there's a root between that interval. Okay, so by using this method, all right, so between -1 and 0, okay, based on your tutorial, because it seems that you guys corrected your range, that your interval, so it's okay. I'm sorry, at least one must lie. Okay, so I am correct. Like, in a way, at least one root must lie between A and B if f of x is continuous. That is a good, yeah, that's really similar to the term that I learned. So it's best that you understood that, okay, at least one root. There is at least one root in the interval, meaning that there can be more than one root. Okay, so that is important to remember. Okay, there's at least one root. Okay. Okay, so to those who watch on YouTube, okay, I already corrected my explanation a bit. Okay, and I'm naive. Okay, so let's I'm gonna read the question again. Show that there is a root, okay, at least a root between -1 and 0 for the function f of x is equal to x squared minus ln of 2x plus 3 by using algebraic method. Okay, so just show that there's the different signs between those endpoints, -1 and 0. Okay, because this question is, okay, no problem. So show here f -1 -1 to the power 2 minus ln 2 times -1 plus 3. And then from here you could solve lah. So 1, wait, yeah, oh, ln 1, oh yeah, 1. Ln 1 is 0, right? If I recall, yeah, ln 1 is 0. So 1 minus 0 is 1. So basically f of -1 is, oops, -1 is larger than 0. So that's good. Okay, we already found what on our first endpoint is a positive value for the f of x. So now let's try and find f of 0. So f of 0 is equivalent to 0 to the power 2 minus ln 2 times 0 plus 3. Now, as you can see, negative ln 3, this indicates that the value of f of 0 is less than 0 lah, or it means that it's a negative value. So from here, how do we conclude? Okay, as far as I recall, right, the way I conclude is that since f of -1 is less than 0 and f of 0 is less than 0, this shows that there is at least one root between -1 and 0. So that is about my conclusion, okay, based on the method that I used, which is algebraic method. Okay. So any questions so far for the second method? It's really simple. Just show this, and then voila, there is at least one root in between -1 and 0. Okay, unlike graphing, graphing does show there exists one root. Okay, it shows that there's one intersection. But for algebraic, for me, it's better to say that there is at least one root, because we don't know. We haven't graphed yet. We can't see it, so we just assume, okay, since this is true, then there exists one root, at least one, in that particular interval. Okay, so hopefully you guys, okay, wait, can I write, all right, hold on, can I write, since there is a sign change shown that there's at least, yeah, sure, just say, yeah, you could mention about the sign, the different signs, compare the signs for f of -1, f of 0, compare it, then you could conclude that based on what you've been learning on this chapter. So yeah, from here it says that find two values of a and b such that f of a and f of b have different signs. Meaning that, okay, you are telling to the examiner, okay, so here, I already showed you that both of these have two different signs. Therefore, by definition, there at least one root between a and b if f of x is continuous. Okay, yeah, as long as you mention that the sign change. From here, I did mention it by showing the inequality lah, bigger than 0, less than 0. It shows that, oh, that both of them have different signs, meaning that by definition, there are at least one root between a and b. Okay, that is very important. Okay, can you do it, Zaifa? You could put your answer in that way, particularly, but then at the end of the day, please do check with your lecturer, because they are the ones who know the exact answer, whether it's appropriate. But as long as you understand what you are writing right now and you can make it better by consulting with your lecturer, then you're good to go lah. Inshallah. All right. Okay. Anyone else? Anyone else have any questions so far? Okay. All right. Yeah. All right. So, okay. Since okay. Um, okay, so do you guys want more questions, or do you want to go to the next subtopic, which is the Newton's Raphson method? Or do you guys still want to try more 1.1, the sorry, numerical solution of equations? Do you want to do more, or you want to continue on in our next subtopic, which is 1.2, Newton's method, Newton-Raphson's method? Bismillah.
I think we just go to 1.2.
All right. Yeah, so far it's okay, right? As long as you know how to graph, and as long as you don't make any mistakes, you should be fine. Okay, so that is the first one. The first one is just want to tell us that, okay, there exists a root in that particular interval, or between A and B. There is a root. But how do I find that value? How do I know the value of the root? Okay, so we will be using a method which is Newton-Raphson method. Now, if you guys want to, okay, let me open my book, because I really want to. It's not a story lah, but it's just a good explanation on this kind of method lah. And just give me a minute to open the page to find it. 280. Okay. Okay. So this method is just basically we approximate a value of x, which is the root of that particular function. Just trying to approximate. I will be using a formula. Okay, what is the formula? X of n plus 1 is equivalent to x of n minus f of x of n sub n, sorry, and f prime of x sub n. Here is the formula that you will be approximating a root. Okay, so honestly, I don't want to tell more than that, because I just realized that it's not in your syllabus, but okay, sorry. But yeah, this formula is important as long as you know how to apply the formula. But then, I really want to show you why we do the formula. But that's none time. I need to really digest myself into Newton-Raphson method to find how they derive the formula, because I did learn it, self-learn about how they derive it. But as for now, we know that this formula helps us to approximate that particular root. Okay, it's not a good, it's just that it's getting closer to the exact value, but it's a good method to approximate it without using any like software to see the root. Okay, so first you have to like find a initial value for your to find your root lah. Okay, to find the initial value. But first, yeah, before you find the initial value, you have to state your function f of x, define it first, and then find the first derivative of fl. You have to find it. So let's start with a question, KML as well. By using the Newton-Raphson method, find the root of the nonlinear equation. Okay, give us f of x is equal to x plus ln of x minus 5 equal to 0. Okay, by taking 3.5 as the first approximation. Okay, maybe some of you might use this notation, x0 or x sub 0, or if you want to begin with x sub 1, I think no issue. I think there is no issue for me lah, as long as you know how many times you have to do it. And yeah, I think there's no issue regarding of whether you want to do sub n Or yeah, there's no problem in my opinion. My opinion, unless if your lecturers told you that you have to do it beginning with sub one or sub zero, whatever, follow them lah. But as long as you wait, sorry, what is it equal to zero? Okay, as long as you know what is going on, what you're going to do, then there should be no problem. Right now, you are trying to find the value of x to satisfy this particular equation, which is zero. You have to find that particular x value where it is equivalent to zero. So that is what we'll be using this formula lah above. Let me draw a box so that it looks better lah for you guys to see. Oh, box. Okay. So now, by applying the formula, eventually you will get the value of x lah, approximately. It's not the exact value of x, but it's approximately without using any software or whatever lah to find your x value. Okay. So let's begin. Now the toughest part for this is to not make mistakes. That is the toughest part. But I will be showing you how to avoid those mistakes lah by using a calculator, okay? So let's start. Let's find the first derivative. So f of prime of x is equal to 1 plus 1 over x. That's about it, okay? Recall your previous semester as usual. Remember, guys, how to differentiate, because that will be extremely important for integration later on, because there will be a few methods that has something to do with differential derivatives. Yeah, there's something to do with differentiating. Yes, differentiating a particular term so that you could integrate something, well, a function. But anyway, that will be another time. But for now, let's just focus on this particular topic. Okay, let's start with x sub 0 is equal to 3.5 as our initial value. Now, first things first, I recommend you guys lah to write down the formula first. Then you substitute the values. So let's write down formula. X sub n plus 1 is equivalent to x sub n minus f of x sub n divided by f prime of x sub n. Okay. Now, let's begin. So if n is 0, then this term here is 1. So x sub 1. So x sub 1 is equivalent to x sub 0 minus f of x sub 0 divided by the first derivative of f of x sub 0. So now all you have to do is just 3.5 minus, just substitute the value. 3.5 plus 3.5 minus 5 divided by the first derivative, but substitute the value, 1 plus 1 over 3.5. So here you go. Now, it would be tedious, right? It would be tedious if you have to do it all over again for the next iteration and the next one, and so on. It will be very tiring. So my advice is, okay, let me write here. Okay, so in your calculator, you have to write the equation. Okay, I think it will be very useful if you have a calculator 570EX. It will be very useful. So just create an equation. Okay, create an equation first step. Create an equation which is x minus, take the function of f lah. So it's x plus ln of x minus 5 divided by 1 plus 1 over x bracket. Write this down on your calculator lah. Okay, and then on your calculator, saya nak ingat balik tak? The second step is there is a button on your top left. Okay, top left. There is a button which is solve equal to, and then there's this big all caps lah, calc. Okay, solve equal solve to all caps. Solve calc. So this is important because this way you could enter your x values lah without rewriting your equation. So this helps you to reduce the probability of creating an error lah in your calculation. Okay, for me. So let us do it together lah. Okay, so if you guys have any problems, please do let me know urgently so that you guys could get used to it lah. Right? So x minus x plus ln of x minus 5 divided by 1 plus 1 over x. Okay, so let me send you a picture lah, okay, on how does it look like on your screen, supposed to be lah. Okay. Oh, nice. All right. So over here should be like this. Okay. Wait, let me, yeah. Yep. So as long as you got in that form or you managed to create that particular equation, then it should be fine. Honestly, it should be fine. So let me put it down here lah. Yeah, but if you guys are a pro, then no problem. It should be no problem. So let me put it here. So hold up. This is an example. Example. Okay. So you should got this equation, and then you have to press solve calc lah. Solve calc, and then it shows that, and then press the 3, and the step 3. Press. Okay, press this button. All right, and then you will get x equal to 0. So from here, just enter your value lah, which is now is 3.5. Okay, so your value is 3.5. So you should get, or approximately. Okay, before I do that, for me kan, write down up until 4 or to 5 decimal places. The more, the merrier lah. But make sure that it's appropriate in a way. Like for me, I would take up to 4 decimal places. But then to the viewers on YouTube, if you guys have a better recommendation, that you should let me know in the comments. But anyway, take up until 4 decimal places. So you guys should get 3.6923. Okay, 3.6923. So do you guys got the same x sub 1 as me, 3.6923? If you guys don't got it, that I can show the I could start all over again for the tutorial for how to compute it using your calculator. But it seems that everyone is good. Okay, everyone is good. All right, so okay, since everyone is doing well, let's say we'll take one decimal places to the yeah. My lecture also said that, but yeah, since our question here doesn't mention anything, it didn't mention anything. I guess that for now, we should take until 4 decimal places. But yeah, usually questions will let you know how many decimal places you should present your answer. Yes, but since the question just gave us like nothing, it didn't mention anything how many you should take. Yes, as for now, I should take up to 4 lah. But if you want to put more, then that is better, in my opinion. Really, it makes your solution closer to the actual value. But yeah, that's a good advice from lecturer. So if the question states, give your answer in 4 decimal places, then you should take up until 5 decimal places, and then etc. It depends on the question, but yeah, good advice. Thank you for letting me know. All right. So, but let's assume that this question, okay, let's just use 4 decimal places, but the more the merrier. Okay, the more the merrier. There is no issue with it. So from here, yeah, you will find x sub 2. Oops, sorry. I am x sub 2 is equal to 3.6923. minus 3.6923 plus ln 3.6923. Okay, hold up. Okay, I have no space now. Hold on. 3 minus, oh, hello, minus 5 divided by 1 plus 1 divided by 3.6923. Now, oh yeah, my screen is still loading because, yeah, it's freezing currently. Hold on. Okay, 1 divided by 3.6923. Okay, now it's tedious, right? Yes. So as usual, if you want to press solve calc, okay, CLC, then put 3.6923. That is okay, in my opinion. Or a better option is to just press calc again, but don't put the value 3.6923, but put your previous value, which is answer lah. Remember, answer is it saves your previous answer, okay, in a way. So it makes a better approximation. So don't sub in 3.6923, but press answer ANS top lower bottom right. Sorry, bottom right. There is a button that says ANS, the percentage symbol. Okay. First you press the calc button and then you press the answer button. And then press equal again, and you will get 3.6934. Okay. 3.6934. Okay. Sorry, approximate. Okay, so it seems that it looks better, right? It is like there's a consistency. Our first two decimal points, 0.69, and then another 69, but then the back of it, 2334, is not good still. So we have to keep on moving until we find two consecutive values which are the same. That is what we are looking for. So let's continue on this really painful journey by writing down this answer. K34 minus 3.6934 plus ln 3.6934 minus 5. By the way, later on, I already asked my lecturer about which topics that will be featured in our PSPM, sorry, in your PSPM, and I will share that list in our group later on. But madam, her name is Madam Kang, and she told me that later on she will give me the list lah, and then we will start from there. Okay, and we will prioritize which topics because a few topics are for the assignment. So as a student, we have to be efficient. We'll study smart. Okay, okay, that's my advice lah. Just don't focus too much on assignment topics. But if you're interested, then go ahead. Okay, no problem. But since we are students, and we want to pass our exams, then you should really focus on the selected topics in our exam. Okay. All right. So okay, let's continue. 1 plus 1 over 3.6934, and then again, calc answer. Don't need to enter 3.6934. No need. Okay. Sorry. Calc answer, and you will get 3.6934. Okay. Okay, this looks promising. You know why? Because there are two consecutive values which are the same, right? 3.963, 3.6934, 3.694. Meaning that, oh, this is a good one. It's a good one, yeah? So this indicates, okay, I should stop now. Don't waste your time. If you get the two consecutive answers which are the same, leave it as this. It means that, okay, that is my best approximation for the roots. No need to continue on from there. All right. So then you should get the conclusion now. Therefore, hold up. Let me scroll up again. Okay. Therefore, the roots of the function is x is equal to 3.6934. Well, approximately 3.6934. I'm not sure whether I have to write down as a curly the curly symbol. But yeah, just ask your lecturer again whether how do you write down the final answer. But our answer is 3.6934. So the question did not mention how many decimal places we should present our answer. Since they didn't ask, just let it be lah, to be safe. Just let it be. 3.6934 is the best answer. Okay. So that is basically it. as long as you not make any mistakes, that you should be good to go. All right. Okay. Now, okay. Before I move on, is there any questions so far? Like, do you have doubts or like, I want to clear up my mind about this particular like wall that I'm facing. But if there is no issue, then I could carry on to another form of question they might ask. Another one. So if there's no questions, then I can move on. So give me a second. I want to drink. Yeah. Okay. Okay, no questions, huh? Maybe okay.
Yeah,
Okay, there. But you guys got the same answer as me, 3.6934. It's a
yeah, we got the same answer.
okay, nice. So it's okay. How about you, Shafi? Hopefully you get the same answer as me. Okay, as long as you don't create any errors in your calculation, that it should be fine. Okay. Okay, looks great. All right. So there is another form of question which I would like to show, but I will not use the total question. But I'll be using a really simple one, which is um x is equal to square root of 2. Now approximate it up until 3 decimal places. Okay, all right. And our first approximation, let me think. Let's take the value 2 lah. Okay, let's take the value 2. That's our initial value to approximate it. So since it asks, okay, let's approximate until 3 decimal places, meaning that, okay, as what Huzaifa said, he said, or his lecture said, that if the question asks for n decimal places, then you should write down to n plus 1 decimal places. Okay, so meaning that take another decimal place, right, to be more accurate, to be in a safe zone when you try to compute it. What should you do? You should find the function first. Now, how do we find the function? Now, first, square both sides. Okay. Square both sides. You're good. You will get x squared is equal to 2, and then you move everything on the right hand side. Or you take away 2, then you get x squared minus 2 is equal to 0. Then from here, you want to show that there is a particular x value, you will get 0. Right? There is a particular x value that is equal to 0. So we could use Newton-Raphson method. Okay, so let's begin. F of x. F of x is equal to x squared minus 2. And then we find the first derivative. F prime of x is equal to 2x. Now, as usual, write down the formula. It makes you like the examiner, right? Or the lecturer that will like write down like examine your assignment or your working. She will appreciate that, since you frequently write down the formulas, mean that it shows that you don't want to forget it. Okay, so that is it's a good impression that you are making towards them. Okay, so write down the formula. X sub n plus 1 is equal to x sub n minus f of x sub n divided by the first derivative x sub n. Okay, so now we have this. Now, as usual, plug in the formulas. X sub 0, our initial value is 2. So yeah, as usual, grab your calculators, write down the equations and so on and start solving up. So x sub 1 is equal to x sub 0 minus f of x sub 0 divided by f prime of x sub 0. Okay, so from here, okay, now just substitute your values at 2 minus, and then 2 square minus 2 divided by 2 times 2. Okay, this looks great. So you will get the value of, yeah, let me write that first. Divided by 2x. Okay, you will get 3 over 2. Now that is your first value, that's x sub 1. And then continue on, x sub 2 is 3 over 2 minus 3 over 2 square minus 2 divided by 2 times 3 over 2. And then what you should get is 17 over 12 lah, or 1.4167. Approximately 1.4167. And then continue on your working. X sub 3, 1.4167 minus 1.4167 square minus 2 divided by, divided by 2 times 1.4167. Yeah, that's about it. And then you will get the value, which is 1.4142. And then continue on until you get two consecutive values which are the same. So x sub 4, 1.4142 minus 1.4142 square minus 2 divided by 2 times 1.4142, and then you should get, you should get 1.4142. So there are two values consecutively which are the same. Therefore, do you need to continue on? No. Just stop from there and be happy about it because that's about it that you have to find your roots. So in a nutshell, basically, you conclude that, you you conclude that the square root of 2 is approximately 1.4142. Ta-da! There you go. You already approximate an irrational number, which is square root of 2. One of the famous irrational numbers lah, okay, in the mathematical world. But yeah, that's one of the another way they will ask you to apply the Newton-Raphson method. Okay. So, any questions so far? Hopefully there is none. But if you do, you could ask me here, or you want to PM me privately, then go ahead. There is no problem. Any questions? Faham. All right, nice. Saifa, how about the rest?
Listening.
Okay, nice. Shafia, how about you? Faham. Okay, nice. So that's basically it. That's basically it. That's the foundation in a way. That's the foundation of this particular topic lah. That's literally it. But then there will be questions where it's a bit difficult, but as long as your foundation is really solid, then there should be no issue. As long as you know how to be careful, how to graph, how to create conclusions, and how to differentiate, then it should be no problem for you guys to do. Okay. So today is Saturday. Next week, okay, later on, I'll give you the video if you are interested in the proof of the formula. But then next week, I am interested to get into integration. Have you guys learned integration, or are you still in chapter 1?
Yes, we already reached chapter 2, which is the
okay. All right, still in chapter 1, but it's okay. For those who are still in chapter 1, it's okay. You are well, I think next week you guys might get into chapter 2 lah, for those who haven't. For those who have, next Saturday we will be discussing chapter 2. Okay, all right, Shafia, no problem. You could do chapter 2, and then I would like to share a few questions for my course lah, calculus. We do integrations as well, but not that difficult. But it gives you an idea of what it looks like in degree for integration. But it's not that difficult in my opinion now. But then I will show you next week. Okay. So, last, any questions? If not, then I will end our session for next week. Up until next week, yeah.
For me, there's some questions.
All right.
I'm looking forward to questions.
Yes, you do. Yeah, yeah. But yeah, this chapter is really nice lah. There's nothing wrong about it. There's nothing hard about it. The only hard part for me lah, SM025 is the integration, and then the probability, that's a bit difficult as well. Combination, and then you have to deal with binomial, binomial probability, and then there's another one which I forgot, but it's tough lah in a way. But thankfully, I got a good grade for my maths. Yeah. So if there is no questions, I could end our meet here, but with at my recording. Okay. So